proximity effect occurs when two or more conductors carrying alternating current, AC, are placed in close proximity to each other. The magnetic fields generated by these currents interact, causing a non-uniform distribution of current density within each conductor. There are causes. Current carrying conductors with AC current flowing through the conductors creates magnetic fields. Close proximity occurs when the conductors are placed close enough for their magnetic fields to interact. The effects are that it increases current density near conductor surfaces. The magnetic fields from adjacent conductors oppose each other in the center of the conductors, reducing current flow. This forces the current to concentrate near the outer surfaces of the conductors. It increases heat dissipation. The high current density near the surfaces results in increased heat dissipation. It increases inductance. The magnetic fields from adjacent conductors interact to create a net magnetic field, which increases the inductive reactance of the conductors. The consequences include power loss. The increased heat dissipation leads to increased power losses in the system. Cable overheating can happen where excessive heat can damage cables and insulation. There is increased voltage drop, which means the increased inductance can lead to a higher voltage drop along the cables. To mitigate the proximity effect, the following measures can be taken. Firstly, increase conductor spacing. Placing the conductors further apart reduces the interaction between their magnetic fields. Secondly, use bundled conductors. Bundling multiple conductors into a single cable creates a more uniform magnetic field and reduces the proximity effect. Thirdly, use transposition. Regularly changing the positions of conductors in a cable helps to distribute the effects of the proximity effect evenly. Use non-magnetic materials. Non-magnetic materials such as aluminum or copper have lower permeability, reducing the magnetic field interactions.